Hey, yeah, I am.
Fancy seeing you here again. So, we're going to go into standards of encryption and mutable data on the IPFS. Cool. So, you ready?
Yep, awesome.
All right, take it away.
Cool. Well, let's see. All right, you guys see my screen. Cool. So, yeah, I'm Joel, and I'm gonna be talking about DAG Jose. And actually, it's kind of interesting or funny. It was about 1 year ago that we actually kind of kickstart the work on DAG Jose. And it was actually at Denver. So uh, that's pretty funny. So DAG Jose, and basically I'm going to talk about what it is and like why we need standards for encrypted and signed data on IPFS. So the things I'm going to be going over today is why do we need encrypted and mutable data? Why is that important? We're going to look at some existing solutions to this, and then we're going to dive into the DAG Jose standard, which is kind of like something of like an amalgamation of three different kind of existing standards. So this is going to be fun. And then finally, we're going to talk about some applications of this stuff. All right, so why do we need encrypted mutable data? Why is that important? IPFS kind of already is an authenticated data format, or rather IPLD. So IPLD is this like linked data structure, and you can with IPLD you can kind of represent, of course, like IPFS data, but you can also represent like Ethereum, Bitcoin, Git, and like other types of linked data structures. And if you have the hash, you can like kind of authenticate that when you sync the data, you can know that you got the right data. And since you have like links in kind of the first object, you know that like all the data that's subsequent or like linked from that object is the data that you expect it to be. So what will we use encryption and mutability for? Well, what if you want to know like who created the data? The kind of hash doesn't really say anything about like who authored the data or who changed the data. If we get like a new hash, and who can read the data? Like by default, like putting stuff in IPFS means that it's like pretty public. And the first thing, like who created and changed it, like we can use signatures to kind of deal with signatures, and like you can use a public key to verify that this was signed by a specific party. And who can read the data, we can actually kind of use encryption to manage access control. So the kind of existing solutions that exist and have been used and is still being used for these different things. Like the first thing, kind of, I think, most commonly known about way to do this is to just take the IPFS hash or the CAD, put that on chain, and now you kind of have, well, you have the signature for the user that made the transaction, and you have like the latest update, and then you can like make another transaction to update the hash and the data. But this is obviously like super expensive, especially given like current gas prices. And then you have stuff like IPNS, which is basically like taking a public key and signing some data and then publishing that in the IPFS DHT. But it's kind of slow, and you can't really do interesting stuff like changing like who is the controller of that data. Then you have more sophisticated systems like OrbitDB and Textile. And these are kind of append-only logs that each entry in the log is kind of signed. So you can verify both the data integrity, but also the kind of cryptographic integrity of the signatures. The kind of not so nice thing about though is like OrbitDB has their own specific way of making signatures. Textile ThreadsDB has like another way of doing signatures, and they're not really interoperable. For encrypted data, we kind of have the same situation there. So Textile uses AES encryption, if I'm not mistaken, and Peergos uses Excelsa poly encryption. And I mean, using different types of encryptions is fine, but we don't really have any way to interoperate between these, because use a specific encryption algorithm and just put the data in some way into IPFS. All right, so we can actually do better, and that's where DAG-HOSE comes in. So DAG-HOSE is like a composition of different standards, and I would say like 3 different ones. So the first one is HOSE, it's JSON object signing and encryption. Second one is, well, it's IPLD, the IPFS native data structure. And the third one is not mentioned this page, but I'm going to talk about it later, is DIDs. The DIDs, decentralized identifiers, is a way to go to represent digital identity kind of, and allows you to do stuff like key rotation, stuff like that. But anyway, so HOSE. So HOSE itself is an IETF standard. There's an RFC for it. Actually, there's several RFCs. And there's a subset of HOSE for encryption, JWE. There's a subset for signatures, JWS. You might know of the better known. There's another kind of subset that's called JWT, and JWT can be either like encrypted or signed. But the cool thing about HOSE is that we can like use different keys. Like the data structure of the HOSE object tells us, oh, this was signed with ED25519 key, or maybe it was signed with like a SICP 256K1 public key. So we can like represent many different types of signatures and different types of ciphers as well. So we could use AES or XCHA or other types of ciphers without kind of breaking interoperability. And it's widely implemented. So I looked at GitHub before, and like I couldn't find the last page when I searched for HOSE implementation. And it's being adopted in or is already adopted in the decentralized identity community. So DAG-HOSE, well, why do we need that? Well, actually, it turns out that HOSE is kind of great, and but we can't really use its kind of full capability in IPFS. If we just put it into IPFS as like a pure data object, so we need like a special IPLD codec. So an IPLD codec is basically a way to represent new data formats within IPLD. So there's an IPLD codec, for example, for Ethereum. There's an IPLD codec for Bitcoin. So you can like actually traverse the entire Ethereum blockchain inside of IPFS, which is pretty cool, but it's not very well known or like commonly used yet. Anyway, so let's look at a signed object. So a JWS, normal JWS has a payload and has signatures, and the signatures consist of a protected header and a signature. So now, why couldn't we just put this into like the IPFS DAG and be done with it? Well, usually when we deal with like IPLD data, is that we wanted to like kind of link to something else. And if the payload actually is just like this gibberish text, this is a base 64 URL encoded string, we can't really follow any links. Like IPLD doesn't know how to like follow something that's encoded as this base 64 URL. So therefore, we kind of need a specific codec to do something about that. So we created a codec, that's the DAG-HOSE codec, and it introduces one constraint. The payload needs to be a CID. And what that means is when you create the DAG JWS, you take the CID you want to link to, encode that as bytes, or you take the bytes of the CID, encode that as a base 64 URL, and then you basically put that into the payload, and then you make the signature over it. Now, when you retrieve the object, the JWS object from IPFS, the DAG-HOSE codec will automatically see that, okay, it's a DAG-HOSE object, take the payload, and encode that as a CID, and put that on the link property, which you can see here below. And this allows us to, like, once we retrieve a DAG JWS object from IPFS, we can automatically like follow the link property and then follow any kind of other path down the Merkle kind of the Merkle DAG that is associated with this like top level DAG Jose, and that could be like just pure IPL objects or other DAG Jose objects, or yeah, really anything like a Bitcoin block or something. So this is great. Like this works really well, but now it's a problem, right? So we made the constraint that the payload or the clear text needs to be a CID, and that's fine for signed objects. But what about encrypted objects? Like if I encrypt something and you only encrypt the CID, the hash, like the data will live in clear text on IPFS, which is like super bad. So we don't want that. So what do we do about that? Well, interestingly, there's a way around this in IPFS, and I'm kind of going to walk you through how it works. So essentially, we take the clear text IPL data that we want to encrypt. We encode that as an inline CID. And an inline CID is a special type of CID where the hash function is the identity hash. So what the identity hash is basically takes the data and puts the data itself. So you can think of like the identity hash of ABC is ABC. The identity hash of 123 is 123. So the identity hash of your object is basically just your object. So you encode the IPL object into some IPL codec, put that into inline CID, and then you encrypt the inline CID. So now we don't actually point to any other data in the IPFS network. We just encrypted the entire data object as a CID. And then we can put that into IPFS. And then when you like retrieve it from IPFS, you can use like decrypt it. And you will be able to like get the inline CID and interpret the data. Okay, so what's this thing about DIDs that I talked about? So DID, or decentralized identifiers, is a standard for, well, it essentially does one thing really well, and it's going from a kind of tiny identifier that's like did :3 : a bunch of random numbers, which is a unique identifier, and converts that into a DID document, which contains public keys, like your public signature verification key, your public encryption key. So I can get this identifier and then find your public encryption key, then encrypt the message to you. And this kind of makes it kind of very well suited to do something like DAG Jose, so we can like easily verify who made the signature and like easily encrypt data to another user. And we implemented, or we kind of created something called EIP 2844, which is like a JSON RPC extension to, well, really any wallet. So it's essentially like three methods. It's did authenticate, did create JWE, create JWS, and decrypt JWE. And any wallet can implement this. And it's not really tied to Ethereum. You can implement that as like a Polkadot wallet or like a Near wallet, and you kind of get the same benefit, like because the DID spec is blockchain agnostic, so you can use a DID that's like native to your blockchain, or you can use the 380 method, which I'm going to talk about a little bit later. We also built like a consumer library of this JSON RPC interface called JSDID, which allows you to like encrypt and decrypt objects and like sign objects and verify signatures of objects. And then on the wallet side, there is like the key DID provider for ED25519. It's like a very simple public-private key pair-based DID. There's 380 Connect, which allows us to do like more complicated things, like have multiple authentication methods and stuff like that. I'm going to talk about that a little bit more at the end. And yeah, essentially, like you can have the wallet separated from the app, and the app can do stuff with JSDID, like create DAG Jose objects and put them into IPFS. All right, so can we actually use DAG Jose? Like that sounds super cool. And yeah, you can. In JS IPFS, it's fully supported. And you can use it by importing the JS-IPFS library and importing DagJose, like putting them together, and then it kind of just works. Or you can install our bundle that we built, so at Ceramic Network / IPFS daemon, and there's an IPFS bundles that bundles these two things together. In Go IPFS, support is coming very soon. So the DagJose codec has already been implemented for IPLD Prime. So IPLD Prime is the kind of next version of IPLD, which is used in Filecoin, but it's not yet used in IPFS. But the IPFS team is telling us it's coming very soon. So we'll be compatible there very soon. So yeah, looking forward to seeing like more applications built in kind of this way once more support in IPFS is there. All right, so what are the applications for DagJose? Like, yeah, you can store data. What do you do with it? Well, the first thing is, of course, like we can upgrade existing protocols. So Textile could start using DagJose, and actually the DagJose was kind of inspired from a discussion with Carson from Textile last year at Denver, and they're kind of already started experimenting with it. OrbitDB also has on their roadmap to kind of look into DagJose, and there are some other kind of protocols that looking into it as well. And we could potentially create like other types of protocols for like event logs in different ways, or CRUTs in different ways. You can do like one-off signatures or one-off encryption. It's not really a protocol. You just want something that to represent this signature or encrypted object. That's also fine. You don't need like a protocol that uses this. And finally, Ceramic Network, which is a project that we've been working on at 3Box Labs. So I'm gonna dive in a little bit to Ceramic and kind of explain like what it is and why it's using DagJose and what we can do with it. Like once we have like built the kind of core layer thing and built the protocol on top, like what can we do with that? So Ceramic is a decentralized kind of framework for mutable information. So in Ceramic, we have something called documents, which is basically an object which has like a persistent identifier that never changes, but it's still mutable. So you can change documents however much you like without changing the identifier. And we kind of get strong data integrity from partly the signatures, but also from updates are anchored into a blockchain, which gives us like timestamp and provides us with the ability to do secure key revocation and stuff like that. And since we can represent like a bunch of different documents in Ceramic, and we can also link the documents to each other, we can create this kind of graph of interlinked documents that is like ever evolving and like changing. And yeah, so in Ceramic, we have the concept of document types, and we have implemented two types, which is tile, which is kind of like a generic JSON object document, or the store JSON object and update that. Type 10 link is a doc type that allows you to link a blockchain account to a DAD. So you can link like your Ethereum account to a DAD, you can link your Polkadot account to a DAD, you can link your Near account to a DAD, or you can link all of them together to one DAD. So yeah, that's pretty cool. You can like link a bunch of blockchain on-chain accounts to this kind of decentralized off-chain data system. And you can potentially like create your own doc type, and there's full support for like Ceramic is kind of like has this framework which allows you to build different types of documents. And this is useful if you want like some different type of logic that goes into your mutable data. And right now you can do like a few different things. We're working on like abstracting this a little bit more. So potentially in the future, we could represent like an OrbitDB database in Ceramic, or maybe like a Textile database in Ceramic. But that's pretty like still quite far off, but there's still like a bunch of powerful things you could do with like custom doc types. All right, so let's actually jump into kind of the data structure. Like, how do we actually use DAG-Jose in Ceramic? So what in this picture, what you see is basically a Ceramic document and the data structure of the Ceramic document. So first we have a Genesis commit, and this is an IPLD object which contains the first kind of initial content of a document. Then this document has an anchor commit. The anchor commit basically is another update to the document that contains like a proof that this document has been anchored into a blockchain. And here this document has two signature commits, and these signature commits are of course using DAG-Jose, and this is signature from the controller of the document, which was specified in the Genesis commit. They're stored. The updates to the content are stored as like JSON patches. So DAG-Jose commits the signatures, and then like another anchor commit, and in the signature commit, and it kind of goes that way into the kind of future. So that's kind of the basic data structure of a document. And of course, like this would be super expensive if you needed to pay for every like anchor commit yourself to anchor it into the blockchain. But what you can do with Ceramic is you can actually take a bunch of documents and create a Merkle tree that we put into IPLD, and then put just the Merkle root into the blockchain. So we have like one transaction for a bunch of different documents that are being updated at once. And the cool thing about having that in IPLD is that we can sync like a specific Merkle witness over the network. So if I only want to sync my document, I don't need to sync the data of like a bunch of other documents. And yeah, there's a bunch of other details here, but I'm not going to go into any more detail there right now. There's some stuff about like how do we do conflict resolution and stuff, and basically the thing is that the earliest anchor wins. If you have any questions about that, you should jump into our Discord. All right, so what can we build on Ceramic? Like now, once we build Ceramic on top of DAG-Jose, what can we build on top of that? So I think there's a bunch of interesting things. One thing is governance, and we're working with some projects that are building some interesting things using Ceramic there. So like discussion forums, potentially like voting is a really good use case because we have this kind of integrity of the data where it's like timestamped and anchored, and signatures of every participant. We could potentially do different forms of like dispute resolution, because like a Ceramic document is a digital audit trail. Or maybe we can do some cool recording contracts where the contract can be updated if it's signed by your lawyer and your counterparty. Publication is a really interesting use case. You could do like research publication, journalistic publication, publication of open source intelligence. The really interesting aspect. One thing that we're building in 3box Labs, it's something called Identity Index. And Identity Index is essentially like a kind of like a decentralized user table. So like putting putting data about the users in control where the user is. So you don't really need to store a bunch of user data on your servers. Rather, they just live on a decentralized network where the user has full control over the data. Like any kind of blockchain metadata or metadata about the blockchain account. It can be like profiles for the users, like skill trees, like things you've done or things you can do. Different types of reputation could be built there. Private data storage, you can put encrypted data into ADX. You can take ADX and point to data that lives in like Textile or BTB or some centralized data store. And you can build a bunch of other cool stuff with ADX. All right, finally, I mentioned that I was going to talk briefly about 380 Connect. So 380 Connect is kind of like a thing that allows you to use the EAP 2844 DID specification with any wallet. So 380 Connect is like a wallet agnostic authentication system to your 380 DID, and it's also blockchain, so I could authenticate with MetaMask or through Wallet Connect or some other Ethereum wallet, or like Polkadot.js, or like or Near Wallet, or some other kind of blockchain wallet system, and to authenticate to like this DID. And the cool thing is you can actually have the same DID be authenticated to from both your Ethereum and your Polkadot wallet, which means that all the data that you've kind of created for a profile and stuff like that, you can actually take that with you to the Polkadot ecosystem. You use an application there, which makes kind of data really kind of interoperable, which is like the power of kind of using these standards for like signed encrypted data in IPFS, and by extension, like you kind of get this interoperability of data that can move between different blockchain systems. And yeah, the 380 DID method is really cool because it's just a ceramic document, and by virtue of being a ceramic document, we can do like secure key revocation without having a blockchain, or we kind of have a blockchain. We kind of anchor stuff in a blockchain, but the document itself is not really a blockchain. And since we can do secure key revocation, we can have multiple authentication methods, just like the example I just mentioned. All right, so I hope you found that interesting and really want to dive into creating stuff with signed encrypted data on IPFS. And if you're interested in like learning more about ceramic, you can go to our documentation page at developerceramic.network, or check out IDX. And you can find us in Discord and probably in all of the other cool venues here at Timber. All right, thank you all.